Hello, students. We are going to tackle mathematical connections. And for this section, you have 3 through 5 and 12 through 17. So 3 through 5, you have an argument here. A student is kind of giving you their way of getting from the opposite of A times B is equal to the opposite of AB. And they're going to show you these steps. Your goal is to figure out, is this a valid argument? Do the steps follow? Give a reason for each step. And if it's not valid, so maybe something was incorrect in here, then say why. Why is this not valid as you go? Okay. So again, trying to get yourself in the mindset of not just creating these arguments, but trying to evaluate them. What is good or not so good about a particular argument? Okay. Once again, here's another one. This is, why is it true that A minus B equals A plus the opposite of B? Here's the proof that the student did. And kind of here's, they started at the top. They did a little something here, worked their way down. Is this valid? Is this an okay way to do things? All right, so that's the idea here. Does this look good to you? What would you say to the student? If not, maybe provide a little bit of explanation, a little nudge, and say, hey, I see what you're doing, but our goal is to show these two things are equal. How to find the number of integers between x and y if x is less than y? That's a great problem-solving type question. Okay, so again, if you're thinking about it, do it with some numbers. Pick some numbers. Hey, I know that 2 is less than 7, for example, right? And how many integers are between them? So again, if I was looking at this, I'd say 2, 3, 4, 5, 6, 7. Okay, so how many are between them? And I see 4 between them. Your goal is to kind of say, okay, that's great. So if I know that y is 7 and x is 2, then there's 4. But could you kind of create a pattern? How do you know just from looking at the 2 and the 7, right? So if I gave you 23 is less than 77, like what would that number be without writing them all out? Okay, that is the kind of question we are looking for in number 5. Okay, let's see here. So what, 3 through 5? And 12 through 17. Okay, so now we're dealing with some student questions. Oh, if n is an odd integer, is n squared even or odd? Interesting. In the last chapter, in chapter 4, we said if n squared is odd, is n odd? Now we're doing the converse. So again, some of you are already kind of thinking of the converse, but in this case, we're actually attacking it. So again, is it true or not? Justify your answer. Remember, for this class, I am looking for, instead of just saying, here's an example, look, 3 is odd, 3 squared is odd, so therefore it's odd. Is it always the case, or did you just happen to fluke into something there? Okay, let's move on down. Ooh, we've got a student in class does not believe that -5 is less than -2. The student argues the debt of $5 is greater than a debt of $2. Question for you. How do you respond? Okay. And again, sometimes a student may be completely correct with their statement, but that's maybe, just maybe, not what we're asking about in that previous question. A student computes -8 minus 2 less than this. Yeah, they wrote -10 times 3 times this. How would you help this student? All right. So again, you can see their work. They kind of simplified this expression. They rewrote it this way. They multiplied and got that number at the end. How would you help the student? And if you wanted to, you could even kind of create an example of a problem that demonstrates this, right? Just like you had in the previous homework section, there was the lab that is at this temperature and it's dropping by this many degrees, or something along those lines. See what you can do with that if you'd like to make it into something that's more tangible. So 12 through, let's see here, 15. Student says his father showed him a very simple method for dealing with expressions like the opposite of x minus b plus 1 and x minus the quantity 2x minus 3. The rule is if there's a negative sign before the parentheses, change the signs in the parentheses. And Okay, so this becomes this, and this becomes that. All right. What is your response? Does this work? I gotta tell you, if you once you get into the classroom, you'll realize you're going to deal with quite a few parents and parents who may have a different idea about how to how to present certain concepts. Let's see here. Mariana felt that absolute values with multiplications were too hard to be taught to middle school students. How would you respond based on the Common Core standards? And again, this textbook is geared for kindergarten through 8th grade. Many of you may only be teaching up through the 5th or maybe even the 6th grade. But seeing the mathematics that comes, so you understand what you're building up to, is pretty important. So again, how would you respond if they felt they were too hard to deal with absolute values with multiplications? And let's see, you're in solving the problem, 3 times 2 minus the opposite of 5. Annie changed it to this, and then wrote this, and then wrote 21. Is she correct? What would you say to her about the order of operations? Okay, so is this on the right track? And those are the big ones there, 12 through 17. So that about that about does it for this section. If you do have other questions about it, need a nudge in any direction, please let me know. I can make a second video. That's it for now. Off you go.